Hello everyone. On behalf of State Council, Science, Technology and Environment, once again I would like to welcome all the viewers and especially my students to this online classes. So today I will continue my lecture on the same chapter that I did in the last class, and the name of that chapter is Magnetic Effect due to a current. So last class I have discussed with you how to trace a magnetic field and a magnetic field lines with the help of bar magnet and a magnetic compass. So in the last class I consider a bar magnet, but this is the north pole and this is the south pole. So I cut something like this, and this line is called the magnetic field lines. And the direction is from north to south. So today I'm going to discuss some characteristics of magnetic field and magnetic field lines. So let me first start with a magnetic field. Alright, there is characteristics of magnetic field. So point number one. The strength of a magnetic field is a vector quantity. Strength of a magnetic field is a vector quantity. So it has a magnitude as well as direction. Why it has magnitude? Because the magnetic field can be measured and can be calculated. And why it has a direction? Why it has a direction? As you can see here, this magnetic field lines has a direction. It starts from north to south. So this will identify the direction of a magnetic field line. So magnetic field is a vector quantity. Point number two. Closer the magnetic field lines more will be the strength of magnetic field. Let us see in this diagram. Let us consider this region and this region, right? Closer the magnetic field lines, more will be the strength of a magnetic field. As you can see here, these two lines are close to each other. So the magnetic field in this region is more as compared to this region. As you can see here, these two magnetic field lines are far away from each other. So it will experience a lesser force as compared to this region. Point number three. Strength of magnetic field strength of magnetic field at a point, and a point depends on the distance from the poles, right? So greater the distance, less is the strength of magnetic field. Let's have a look again at this diagram. Let us consider this point and this point. Let me mark this as point A and this as point B. So, let me draw a straight line from the North Pole to this point A and another straight line from point B to this North Pole, right? So, let me compare these two distances. So, this line is much longer than this line, right? So, point B has more distance as compared to this point A from the North Pole. So, point B will experience a lesser force and point A will experience a more force as compared to point B. So, we have greater the distance, less is the strength of the magnetic field. Next, so I'm going to discuss the characteristics of a magnetic field lines. So, let me redraw the figure. So, this is a bar magnet. This is a magnetic field lines. Let me draw only these two, and the direction is from the North Pole to the South Pole, and North Pole to South Pole. Point number 1. So, point number 1, a magnetic field lines is a closed curve. And what is a closed curve? Closed curve is something which is not open. Let me consider this curve. As you can see, this is closed, right? Why? Because let me consider again. I start from here and end up in here. So the starting point and the ending point are meeting at this point. They meet together at this point. So we get a closed curve. We compare with this. I start from here, I end up till here. The starting point and the ending point does not meet each other. So this is an open curve, right? Come to this. Here is a magnetic field lines, and I have written here magnetic field lines is a closed curve. You might say that this magnetic field line is not a closed curve, but actually this line will continue to move in this direction. So we now get a closed curve. Again, for this other line, this line will continue in this way to form a closed curve. Point number 2. Magnetic field lines magnetic field lines move, start from North Pole to South Pole outside the magnet. As you can see here, these magnetic field lines start from the North Pole and end up in end in South Pole, right? So, what about those magnetic field lines inside this magnet? Within the magnetic field lines start from North Pole, not from North Pole, from South Pole to North Pole. How to show that? Inside this magnet, how to show that the direction of magnetic field lines start from North Pole to from South Pole to North Pole. With the help of magnetic compass, you place it here. This is a magnetic compass which has a needle. This is the North Pole and this is the South Pole. Since this is a magnet, this is also a magnet. It will experience a force of attraction or repulsion, right? So, because this is the North Pole and this is the South Pole, so South will attract North, right? So this arrow will come in this direction, right? So it moves in this direction. So what about in this direction? This is a magnetic compass. So this is the North. So the North will repel the North. North will attract South. So the North will get repelled like this. So within this magnet, inside this magnet, the direction is start from the North to South Pole, or from the South Pole to the North Pole. So point number 3. No two magnetic field lines intersect one another. Magnetic field lines should not be intersect. Let me explain. Suppose this is a bar magnet which has a North Pole and a South Pole, and suppose that this is one magnetic field line starting from North South, and suppose we consider another magnetic field lines such that the two field lines intersect one another. Start from here and here. So what will you observe? You will observe that these two curved lines will meet at this point, right? At this point. And you will see that at this point, the direction of the field lines will break into two, right? One going this way and the other one going in the other way. So, is that possible? Let me give you one example. Suppose you are the captain of a ship. You are in the middle of the sea and you have with you a magnetic compass. So, you have with you a magnetic compass. this is the north, or this is the south, and this is the north. So, will you expect that this magnetic compass will give you two direction, or will you expect that this magnetic needle will break into two and give you two direction? Suppose this needle will break into and give you two direction. Will that possible? Will that possible? No, right? So we can conclude here that no two field lines will intersect one another. So that's with a characteristic of magnetic field and magnetic field lines. We're going to introduce another topic, that is a solenoid. Solenoid. Let me first write a definition of a solenoid. Solenoid, an insulated copper wire wounded on some cylindrical cardboard or plastic tube such that its length is greater than the diameter, and it will behave as a magnet when current is passed through it. So this is a solenoid. This is the definition of a solenoid. So I have with me here a cylindrical tube, and make sure that the length of this tube is greater than the diameter of this tube, and I have with me a copper wire. So I will wound winding this wire around this tube. So like this. Keep on winding, and I got something like this, right? I got something like this. So this is not a complete definition of a solenoid. To make it complete, you connect this two ends of the wire to a battery. So let me draw in the board. You have this solenoid. First we draw the tube. This is a cylindrical tube. So, and this is the copper wire. I would like this. So this is incomplete. So to make it complete, I connect it to a battery. And this is a battery. And also we must include the key. This is the key and some resistance. So first, the current is still off, right? So now we'll on the current by pressing the key. Now I close the key and the current start flowing, and it will flow through this wire. It will flow through this wire. So when the current is flowing, this solenoid will behave like a magnet. And how that happen, right? So when I connect this solenoid to a current, the current start following this wire and make this coil to behave like a magnet. This coil will behave a magnet. So if this act as a magnet, so every magnet has a pole. So we will identify which is the north pole and which is the south pole, right? So we will indicate the polarity of this solenoid with the help of the direction of current. And there are two directions. One is clockwise direction and the other is anti-clockwise direction. So as for now, I think we will stop up till here, up to this definition of a solenoid. So next class we will discuss the magnetic field of this solenoid. So thank you so much.